Okay, we're going to do some problem solving today. Problem solving examples that we're doing, the point of these is to go through the problem solving steps. Okay, the point of this is not to do a simple little geometry problem. Okay, the point of this is to illustrate all 7 steps of the problem solving method. We're going to use these 7 steps to solve much more complicated physics problems as the year progresses. But these 7 steps will never change, even though the vocabulary and the physics equations will. Okay, so we're going to use a simple problem, this example 1.9, and we're going to do the problem solving steps. Okay, so the first step is to list the data and what is to be found. So what is to be found is probably the most important part. What is to be found is the target or the question. So our target this time is usually the last sentence of a paragraph or a problem. It's, what's the area of the room in square meters? Now, the what is important, which is area, but also the units, meters squared. It's a specific target. We don't want to solve for miles squared or feet squared or inches squared. We want meters squared. And that's fine because those are metric units. In science, we want to use the metric system pretty much all the time. Now what I'm doing next is step 2, which is drawing a diagram. Now we haven't really completed step 1. Step 1 is also list the data. So when we say list data, it's also list givens. I'll say list givens all the time. And a lot of times your givens can be written in the diagram, right? So when you draw a picture or a diagram, so I'll always say, did you list your givens? Did you draw a picture? Usually you do that together. You draw a picture and you put your givens like right next to or within the picture or diagram. Kind of like a blueprint. So it looks like we have some data. We have 15 feet 8 inches and we have 4.25 meters. Okay, because I've done this problem a bunch of times, I know that the 15 feet 8 inches is the longer side. So that'll correspond to the longer side in my diagram, and I'll call it L for length. So the length is 15 feet and 8 inches. Okay, so we've put our target, we've listed what is to be found, which is the question. So you list your question, you list your givens or data, which is what we're doing now, and we've drawn a diagram. So I've done like those 2 steps. They're really 3 things, right? And we do that together right there in the question. We have the picture and the givens or data right there next to each other. Okay. Yeah, it seems tedious, but if you guys don't do all the problem solving steps, you're simply not going to earn all the credit. Okay? All the problem solving steps are important. If you don't show them all, you don't get all the credit. Why is it important to keep practicing these steps? Because there's going to be more complicated problems that you guys are going to do later. And doing these steps is going to help you make progress when you feel like you're stuck. And it'll help you take the next baby step forward to solving a real complicated problem in the future. This is a real simple example. So our next step is to look at equations or principles. Well, yeah, we know a principle or equation of geometry, area is length times width. So you need to list it. If you don't list your equation, you're not doing the full job. Okay? A lot of people tend to skip this step later, but you have to justify, you're going to do a bunch of math later, but where does it come from? What's the principle that you're using? Length times width is area. That's a sound like principle of geometry. Like, okay, I can count on that. I understand what you're doing. That's fine. Okay, so if we listen to our equation, the next step is to think about our units. Are there any units we need to convert? Well, we need to solve for our problem, right? We go back to our target. Our target's meters squared. And 15 feet 8 inches is not meters. So what we got is 8 inches, 8 over 12 feet, right? 8 inches because there's 12 inches in a foot. So 15 plus 8 over 12 feet is our length. And 8 over 12 is 0.6 repeating. So really our length is 15.7 feet. Why did I round to 3 sig figs? Well, if you look at the problem itself, 4.25, 15, and 8. there's three significant figures in all our givens. And the rule of multiplication and division is you keep the least amount of sig figs that are there. But it's three. So the out of 3 and 3, the least amount is 3. So our sig figs, really, it's a 3 sig fig problem. Okay? So we're going to convert our feet, 15.7. We got a nice decimal. We should always use decimals and not fractions. But also, we have a nice decimal, but it's still in feet and not meters. So our conversion factor is 1 foot, and I happen to know that 1 foot is equal to 0.305 meters. So that's our conversion factor. The feet goes in the bottom. Okay, we're doing dimensional analysis. And whatever we're trying to change or cancel goes in the denominator. So the 1 foot's on the bottom, and that's going to cancel with the feet in 15.7 feet. And then we multiply. Okay, we're multiplying two numbers with 3 sig figs. So our final answer should be 3 significant figures. And we got 4.7885. So really, my answer, right, if I round it, should be 4.79 meters. But I don't know. I think I might make an error here. I think I remember doing this wrong to begin with, and then I changed it later. 4.789, right? Because 88. Okay. So we've canceled our feet in the denominator, and what we're left with is units of meters, and it should be 4.79 meters. Oh no! I better correct that later, shouldn't I? Because I should have rounded up. Okay, so we got 3 sig figs. We have a slightly wrong number written there, but hopefully we'll catch that error later, huh? And that's just the length though, right? We're not done. What we have to do is use our equation and solve for our area in meters squared by doing length times width. So we should show our work, okay? So this is the last step, is to solve, okay? Well, second to the last step, really. I think it's step 6 here. So we've got 4.78 meters, which should be 4.79 meters, and it's going to be our length, and the width is 4.25 meters, the shorter measurement, and that's going to equal our final answer. So it looks like I multiplied this out, and I think I caught my error because I always know what the final answer is supposed to be, so I can catch errors. But I said, oh, 20.3. Wait a minute, that doesn't sound right to me. And so what I did here is I double-checked my conversion of 15.7 feet to meters, and at 4.78, oh, 88, I need to go to 89. So sometimes it's good to always double-check what you're doing. In my case, I was lucky to know to double-check because I already knew what the final answer was supposed to be. So that's me catching my error, sorry. But sometimes, even in the simplest of problems, you have to like go over your work and double check things. So this was 4.79 meters. It was 3 sig figs, and we had to round up correctly. So 4.79 meters times 4.25 meters is our length times width, and that is equal to our final answer, which I think it's 20.35. So we round up to 20.4 meters times meters, so it's 20.4 meters squared. That is the area of the room. And that's my final answer. And once you get to your final answer, you got to remember you can't leave your numbers without a unit. Like I say, it's naughty. There's no naked numbers, I say to everybody. You can't just have a number and without a unit. Okay? If someone said, oh yeah, I'm 16. Oh, 16 inches tall? Oh no, I'm 16 years old. Well, why didn't you say years? You left out the unit. I don't know what you're talking about. You just said you're 16. 16 pounds. 16 feet. Or what are you? I'm 16 years old. So, I mean, like, if you're not specific, you know, people can misinterpret things. That sounds like a ridiculous example. But in this case, it's 20.4 meters squared, and that's what we're supposed to report. The area in the metric system. Now, for every problem, you should box your answer at the bottom so we know that what you solve for, that's the final solution. And there we go. We got our meters squared and our correct number. That's the answer to our question. And the last part of the problem solving is to check your final answer and see if it's reasonable. So 20.4 is essentially, what do we got? We got about 4 yards by 4 yards. because it's about 4 by 4 meters or 5 by 5 meters. So that's a reasonable size for a room. So that'll work. So those are the 7 problem solving steps. And we'll do another example. I'll do a YouTube again later. Ciao.